How's it going today, guys? Today we'll be covering scientific notation, and I'm going to go over a quick review for what scientific notation is and how to use it. First off, scientific notation is a way to express very large numbers using an expression that will indicate a multiplication times a base 10. So for example, if I want to find out how many atoms are in 12 grams of carbon, and let's just say I use this number, I don't want to use the entire number because it is such a long number with a bunch of zeros. So what I do is I convert that to scientific notation. Now, in most cases, a lot of the answers will have to be in scientific notation. So the way it would work is that you would find a number between 10 and 1, and then multiply it by how many zeros or how many decimal places that number moved. So 6.02, you would put a decimal point here and run it across, which would give you 23 places, which would indicate that it is a base 10, meaning that you multiply by a 10 and it will move the number back to the right. In this case, you actually have the opposite. You have 1.99. So what we would do is we would try to find a number that is going to be less between 10 and 1 again, but instead we're going to move our way back from these numbers. So a 1.99 would indicate that I would choose a decimal point right here and move our way back. But because it is a number less than 1, it would indicate that it would have a negative exponent. So in this case, it would be 1.99 times 10 to the negative 23. The general rule is going to be you're going to find your n, which is going to be between 10 and 1, and you're going to multiply it by n, which is going to be how many zeros you have. So n is going to be a number between 1 and 10, and n is going to be either a positive or a negative integer depending on what you have. Any number less than 1 will be considered to be a negative integer, and any number greater than 1 will be considered to be a positive integer. Scientific notation, let's take a look at the first one. First, you're going to move the decimal to the left, so when you get something like this, 568.762, you would first want to pick a number between 10 and 1. So you would move the decimal point to the left. If you move the decimal point to the right, you would exceed a number of 10. So because it would do that, the number would be greater to 0. Your answer would be 5.68762. You would keep all these numbers, and then you multiply it by 2. Now again, this number would indicate that you move the decimal point to the right 2 times. So 1, 2. Now what if you get something like this, 7.72? So what would you pick between 1 and 10? So the answer for that would be a 7. So it would be a 7.72, and you're going to move the decimal point to the right. So because this number is already less than 1, the only possibility is to move the decimal point to the right. 1, 2, 3, 4, 5, and 6. So you would have 6. Because it's less than 0, you would have a negative 6 instead of a positive 6. For addition and subtractions, if you don't have a calculator, in some cases of the test, you're not going to be allowed to use a calculator. A great way of using scientific notation is finding these little small tricks. First off, write each quantity with the same exponent, and then combine n1 and n2, and then the exponent remains the same. So here we go. So here's an example of 4.31 times 10 to the 4th power plus 3.9 times 10 to the 3rd power. In this case, the exponents are different. So because the exponents are different, you cannot be able to do a regular addition here. In order to make one of these the same, you're going to have to convert one of them into scientific notation. Now we're going to be breaking a rule here that indicates it's got to be less than 1 and less than 10 and greater than 1. But because we're doing an addition, all you have to do is change that to a 4, and then you would add the 4.31 and the 0.39, and you would get the same exponent. Now for multiplication, it pretty much works almost the same way. You first would multiply n1 times n2, which would indicate the front numbers, and then you would add the exponents. So here we go. So what you would do here is you would first multiply these. So 4.0 times 7. And then what you would do is you would add the negative 5 and the 3. Now on the multiplication side, it's very easy. It's much easier than addition because you don't have to do any conversions. All you have to do is multiply the front and then add the ones on the right. All right. Once you do that, let's talk about division. Division is going to be very similar to the other one, but instead we'll be subtracting the exponents. So you're going to have n1 and n2, and you're going to subtract exponents of n1 and n2. So here's an example of 8.5 times 10 to the 4th. divided by 5.0 times 10 to the 9. So you would divide the 8.5 divided by the 5, and then you would subtract the 4 minus 9, which would give you a negative 5, and 1.7 to the negative 5. Okay, now let's move over to significant figures, because that's actually something that is very important for the basics for calculations. Alright, so sigfigs are basically any digit that is not zero significant figures. This actually is used for determining uncertainty, the level of uncertainty in a number. So for example, if I have a digit that is not a zero, it is still considered to be significant, which means you will count it as part of your answer. For example, 1.234 kilograms has 4 significant figures because these are non-zeros. So general rule is any non-zero is considered to be significant. Zeros between non-zero digits are also significant. So here's, for example, 606 is between a 6 and a 6, and because of that, the 6 is significant, which means you report out as 3 significant figures. Zeros to the left of the first non-zero digit are not significant. So for example, here we go. The 0 here between 0.08, these two are not significant, so this would be considered one significant figure because it's right before the 8. If a number is greater than 1, then all zeros to the right of that are significant. So for example, 2.0 and it's greater than 1, it is still considered to be significant. So in this specific case, you would have 2 figures. If a number is less than 1, the only zeros that are at the end and the middle of the 0 are significant. So for example, in this case, you would get 3 because these 3 do not count, and these are right after the 4. So very similar to this idea where you have that. So this 0 is still considered to be significant. Alright, so let's go ahead and give you a quick quiz on which numbers are considered to be significant. 24. Ready? Go. So 24 is actually 2 significant figures. The 2 and the 4 are non-zeros. How about 3001? Well, that would be considered 4 significant figures because the 2 zeros are in between 2 non-zeros. What about 0320? In this specific case, you would have 3 significant figures because the 320 are significant, but these 2 are not. So this is a significant figure. How about 6.4 times 10 to the 4th power? In this case, it would be the 6 and the 4 are non-zeros, so that would be 2 significant figures. And then 560, which we would have as a 0, that would be 2 significant figures, because the 5 and the 6 are there, but the 0 does not count. Alright, so for addition and subtraction for sigfigs, the first thing is the answer can have more digits to the right of the decimal than any of the original numbers. So for example, if you have 89332, in this case you have 1 significant figure after the decimal point, so you're going to round off to 90.4. So whatever it is, the shortest one right to the right of that decimal point. How about this one? 3.7 minus 2.9133, you get that. And because this is 2 numbers after the significant figure, you're going to round off to 0.79. Now for multiplication division, it's the one that has the smallest number of significant figures. This is the one that's most common in the calculations. So 4.51, so our smallest number here will be the 4.51. In this case, it is 3 significant figures. And if you actually round this to 3, you should get 16.5. Now the 3 does not come off because that's a rounding error. 6.8, it's same idea for division. You have 2 significant figures, which is your lowest one. And because you're rounding off to 2, you're going to get 0.061. So the 1 will be significant. Exact numbers are numbers from definitions or numbers of objects are considered to have an infinite number of significant figures. So the average of 3 is going to be this. If you go ahead and take the average, it will be 6.67 and not 7. Because again, it's going to be the lowest one that you have. Because 3 is an exact number. So because 3 is an exact number, you're not going to be using it to 1 significant figure. You'll be using it to 3. Alright, closing off with this, just to throw a couple of vocabulary out there. Accuracy is considered to be how close a measurement is to the true value of this. So in this dartboard, This one is going to be accurate. Precision is how close the measurements are to each other. So in this specific case, you can also see that this one is accurate and precise because it has both. And this is precise but not accurate. And this is not accurate and not precise.